Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning our panel and our lecturer. Okay, today I will be presented about my project solar wireless electric vehicle charging system. So firstly, my name is Amirul bin Arifin. My matric number DN200098 and my supervisor name is TS Dr. Faraya binti Mustafa. So this is my project, the table of content of my project. So here we got problem segment, project objective, scope of work, literature review, methodology, bill of material, expected result, conclusion and Gantt chart for PSM1. Okay, firstly, chapter 1, introduction. Okay, the study of recent research on the subject is included in this chapter. All the information that is gathered will be examined in order to improve comprehension of the project central idea. The principle of microwave and inductive resonant coupling are all applied in wireless power transfer. Studies about material of the project and solar also include to manage the system. These methods foundation are examined and their performance are contrasted in order to create wireless charging for electric vehicle. The appropriate principle will be picked. Nowadays there are electrical vehicles accessible, but they are pricier and less common than gasoline powered vehicle. On the other hand, there are hybrid vehicles which use both gasoline and electricity but are not solely reliant on electricity and suffer from a lack of charging station. By examining the key components of the issues has been brought to light in this project. Another of the suggested solution is to place solar PV panel beside the road or the place PV panel with wireless system to produce electricity for EV charging. Incorporating energy storage system into charging station on the roads can increase their efficiency by allowing EVs to be charged directly without stop from moving from PV panels on bright days and storing the excess battery power for use at night and on cloudy or rainy days. This suggestion also has to make the change on the EV with copper coil mounted underneath this vehicle for receiving the power. Okay, so the problem statement here. The electric vehicles can currently only be charged using plug-in connection. The issue arises though when the user needs to locate the charging stations and the charging cord is broken or missing. In this research, a wireless power transmission for electric vehicle is being designed. This project concept is appropriate for all electric vehicles including buses, cars and light trains. Instead of using the conventional plug-in connection, a new practical method to recharge the battery of electric vehicle will be devised. There is no physical connection or touch between the electric vehicles and the power source when wireless power transfer is used to charge them. Because the procedure is totally automated, no human involvement activities are necessary to carry out the bidding process. Although the idea of wireless power transfer is widely established and has been used in industrial setting, its application in the transportation industry are still in their infancy. Another significant issue with the current plug-in cable for electric vehicle is that if the cable system is destroyed, individuals are more likely to experience an electrical shock. Electric vehicles that employ wireless charging can avoid incidents like this because there is no need for wire or cable and the energy is transferred electromagnetically, preventing the risk of the electric shock. So, project objective: first, to develop the prototype of vehicle charging powered by solar energy. Second, to analyze the performance of the system. Third, to apply the wireless power transfer concept for electric vehicles using the concept of inductive resonance coupling method. So for the scope of the project, first here we got to investigate the potential for conductive charging stations to be combined with other forms of renewable energy, specifically solar energy. Second, the project also focused on integrating renewable energy sources into the charging process using solar energy in order to reduce reliance on fossil fuels and minimize the strain placed on the main power system. Third, we got developed the electric vehicle wireless solar charging based on solar system. Next, researching existing solar wireless EV charging system and conducting feasibility studies And lastly, develop the charging indicator using LCD display. So for the chapter 2 literature review, the study of recent research on the subject is included in this chapter. All the information that is gathered will be examined in order to improve comprehension of the project's central idea. The principle of microwave and inductive resonance coupling are all applied in wireless power transfer. Studies about material of the project and solar also include to manage the system. This method foundation are examined and their performance are contrasted in order to create wireless charging for electric vehicle. The appropriate principle will be picked up. Okay, for the wireless power transfer principle, device without wires receiving power transfer. Since Nikola Tesla conduct his first experiment to test his theory for wireless lighting and electrical distribution after successfully developing an alternating current, the theory of wireless power transfer has been well understood. So the wireless transfer of electromagnetic energy is the form of data, video and audio signal is regulating, but it is more recent when it comes to the transfer of electrical power. There are already several technologies that transfer energy wireless without using metal connection. So the wireless power transmission process use range of method including microwave, inductive and inductive resonance coupling technologies. So for the microwave principle, as we know, a transmitted antenna is used in the technology known as microwave wireless power transmission to wirelessly transfer microwave electromagnetic energy into space. Okay, for this technology, convert electromagnetic energy into electric energy and supplies it into power supply after being rectified, filtered and subject to other changes. Due to its high transmission power, excellent environmental versatility and adaptable focus and scattering implementation, microwave wireless power transmission technology is well suited for powering driverless equipment over long distance in challenging environments. Okay. Additionally, this technology could really traverse the atmosphere. Power transmission start with converting as the initial stage. Electrical energy is converted into microwave energy, which is then coupled using a reflector. Alternating current cannot be transformed into microwave energy directly with this technique. As a result, AC must be first converted to DC or direct current. Then, using a magnetron, DC must be transformed into microwave. The antennas receive the transmit wave and more effectively convert them into electricity by rectifying the microwave. As a result, DC will be produced. The final phase will involve converting DC back to AC. Okay, so previous research using this principle, the charging of an electric car can be accomplished by a variety of wireless power transmission. WPT that use include coupling and resonance. Coupling are utilized rather frequently for the purpose of wireless charging. The EV researchers proposed a WPT that would utilize microwave power transfer, also known as MPT. So at the Kyoto University, here they have created two different methods of microwave based wireless charging for electric vehicles. The first is a system for shorter distance that has been in development since 2003. Microwave transmitter that is installed on the road or at parking space, and a microwave receiver that is installed on the body of the electric vehicle. Okay, so as we can see the figure from this figure, from my explanation, the system is comparable to a WPT that use inductive coupling or a WPT that use resonance coupling. So the relationship between a transmitter and a receiver is completely uncoupled. So inductive resonance coupling principle. Okay, as we can understand here, the coupling of two LC circuits with the same frequency response. As an illustration, alternating current in a primary coil linked to a source can produce a changing magnetic field that induces voltage across the terminal of a secondary coil at the receiver. It works by employing magnetic field induction, a natural of current flow through wire. Inductive coupling uses two different coils called primary and secondary coils. Okay, so inconvenient convenience and safety, inductive coupling has become a crucial and well-liked technique for power transmission without wires. Various kinds of electrical devices have been created, such as toothbrush, laptop, phone charging station, medical implant, that have been developed and marketed. Okay, concept of electromagnetism. An electromagnet is created when the magnetic field is generated by an electric current, often flowing via a wire coil. The floating compass provides a simple visual explanation of both this and Heinrich Lenz's law, which was developed in 1833. According to Lenz's law, the flow of current will always be in the direction that is opposite to the change in magnetic flux, which is measurement of the total magnetic field that is traveling through a specific area. Okay, Lenz's law is frequently combined with Faraday's law, allowing the electromotive force and flux to be measured using the same coordinate system, EMF. Many electrical devices, such as speaker, as we can see here at this figure, motor generators, hard drive, MRI equipment, and many others employ electromagnetism to create magnetic field. Okay, so for resonance frequency, the resonance frequency of an object where it typically vibrates with a greater amplitude is another way to describe the resonance frequency. So as we can see in figure here, a circuit with an inductor and a capacitor, the decreasing capacitive reactance and the increasing inductive reactance will meet at a particular frequency. The resonant frequency of an RLC circuit is the frequency at which the two parameters overlap. So definition of inductor: passive electrical component known as inductor stores energy in magnetic field when electric current passes through the coil of the inductor. Okay, An inductor's most basic design consists of two terminal and insulated wire coil that either encircle a core material that strengthen the magnetic field or loop around electric current fluctuations in a circuit are managed with the use of inductor. A small magnetic field is created around conductors such as copper wire when an electric current travels through it. The magnetic field grows substantially greater if the wire is coiled. The magnetic field becomes even stronger if the wire is wound around the core structure composed of material like iron. This is essentially how electromagnet operates. Okay, previous research using inductive power transfer. Okay, as we can see here, wireless power transfer is getting greater attention in the automotive industry. This technology offers safe, flexible, potential fruitful alternative to the conventional battery charges. When these benefits are considered, employing the WPT techniques to charge the batteries of electric vehicles can be an essential alternative to conventional charging system that need plug-in. The inductive power transfer method, which is based on the magnetic coupling of coils exchanging power from a stationary primary unit to a secondary system on board of the EV, is the primary topic of discussion in this research study. Okay, the IPPT method was developed by the National Institute of Standards and Technology. A thorough analysis has been carried out on the history of the development, the operating principles and phenomena, the design concerns, the control methods, and the health issues associated with IPT system. Okay, so the guidelines and research that have been published and that have researched the effects that WPT system have had on human health are also include. In addition, they go over some of the protection strategies that have been suggested by previous research in the relevant literature. The strategy known as constant current, constant voltage CV, which is typically utilized by electric vehicle battery chargers. So for the subject of the control section, which also provides an overview of the prevalent charging control strategies. Okay, so for the photovoltaic system, photovoltaic system, as we know, more commonly referred to as solar power system, are a type of technology that transform light from the sun into electric current. Solar panel are the primary component of this system. This panel contain photovoltaic cells which allow sunlight to be converted into direct current, DC electricity. The direct current power is then changed into alternating current electricity using an inverter. Alternating current electricity is the form of electricity that is typically utilized in a residential and commercial setting. In this system, several types of PV system that are photovoltaic system connect to the grid, and grid independent photovoltaic system will be discussed. So for the first photovoltaic system connected to the grid, as you can see here on the figure above, system is connected to the grid. So the electricity that is created using solar will be inserted into the national grid in order to strengthen the national grid and reduce the strain that electrical demand places on power plants during the day. Photovoltaic systems that are connected to the grid might be centralized or decentralized. The system benefits are that it is simple to install and configure, that is highly effective, and that it does not require the use of complicated device. A photovoltaic system that is connected to the grid depicted in this figure. So usually the system does not need a battery in order to store electrical energy, but in some cases energy storage devices such as battery are deployed in order to improve the reliability of the network. As a result, the grid connected system of energy around the world can be divided into two categories: those that have a storage system and those that do not have a storage system. So for the second system, grid independent photovoltaic system. So as you can see the figure here, the system that operates independently from the grid, it is necessary for the energy storage system to be able to feed the entire load of the system for several days if the weather is bad. Okay, so typically these devices are utilized in locations that either do not have access to the national power grid or where it would to be expensive to connect to the grid. A grid independent photovoltaic system can be utilized, for instance, in high communication bases, nomadic area, rural cottage, and to cover the electrical needs of areas that do not have national energy grid in general. The theoretical foundation as well as the influence that PV system have on the surrounding environment. So for the chapter 3 methodology, we will go through to the process or component that were utilized in this project to make it happen, which is solar wireless electric vehicle charging system. So from here, research methodology, detailed step involved in completing the study, as abilities that were utilized to accomplish the goals, including the specific of the hardware connection. So as a result, having a comprehension of this process is quite significant because it provides a clear picture regarding the function of the project that was built. So for the first system block diagram, okay, as we can see here, this advancement can be broken down into two categories: the hardware categories and the software categories. The hardware phase makes use of a number of important components, the most notable of which are an LCD display, an mega microprocessor, a solar panel, a 12-volt battery, a transformer, regulatory circuitry, a transmitter and receiver coil, and AC to DC converter. It has been determined that Process 8 is currently in the software phase for the PCB design and circuit simulator. So for the system block diagram, as we can see here, so first we got solar panel, second to the battery, after that transformer, regulator, transmitter coil, receiver, AC to DC converter, mega controller, and lastly LCD display. So for the system flowchart, as we can see here, we start first. After that, solar panel receive energy and convert to electric. So battery is charged. If they charge, battery is full. If not, they will return to the battery to charge them until they full. After battery is full, transformer convert DC to AC. Then transmitter coil receive energy from transformer. go to electric car, move along transmitter coil. After that, receiver coil at the base of vehicle receive energy from transmitter coil, which will supply to receiver coil of electric vehicle. Convert AC to DC used to charge EV battery. So mega controller read and display input voltage. LCD display the charge voltage. So after that, the system will end. Okay, for the hardware development, for this section, additional detail will be provided regarding the component connection, hardware, and the components that were utilized in this project to construct the system component, including a solar panel, battery, transformer, regulator circuit, copper coils, and AC to DC converter, and a mega controller, and LCD display are utilized. The next step is to use Process 8 to design the circuit simulation of a mega controller connected to the LCD display, then run the simulation and check it against the real circuit. So these are the schematic diagram using Process 8 for the connection of a mega 3 to 8P connect to the LCD display. So for the bill of material, we got here first at mega 3 to 8P microcontroller, and the price RM34.90. LCD display 10 ringgit. LED the price is 1 ringgit 20 cent. Transformer 35 ringgit. Solar panel 99 ringgit. Strip board 4 ringgit. Coil 7.90 cent. And lastly, wire 6 ringgit and 32 cent. So the total of the bill of material we get here 198 ringgit and 32 cent. Okay, so for the chapter 4 result discussion, as the expected result, the system will construct component including a solar panel, batteries, transformer, regulator circuit, copper coils, and AC to DC converter, and mega controller and LCD display are utilized. This method display how electric vehicle can be charged while they are driving on the road, eliminating the need to stop for charging at a designated charging station. Through the employment of a charge controller, the electricity from the solar panel is transferred to the battery. The battery may be charged and has the capacity to store this power. It is now necessary to change the DC electricity into AC so that it may be transmitted. In order to accomplish this goal, this project made use of a transformer. The electricity is first transformed from DC to AC by a transformer, then regulated by a circuitry in the regulator. This power is now used to power the copper coils that are used for wireless energy transmission. Those coils are used transmitting energy wirelessly. Additionally, a copper coil is attached to the bottom of the electric car. Energy is sent from the transmitter coil to the EV coil whenever the car is driven across the coil. This coil continues to receive energy in the form of DC current because of the induction process. Okay, furthermore, for this to be able to be used to charge EV battery, it will first need to convert this back to DC. In order to convert it back into DC current, this project make use of AC to DC conversion circuitry. It is necessary to measure the input voltage with an microcontroller and then display the results on an LCD display. Therefore, the system illustrated solar power boiling charging system for electric vehicles that is capable of being integrated into the road. Okay, for the conclusion, in conclusion, we got here a prototype of vehicle charging powered by solar energy have been developed. Furthermore, the performance of the system on this project also has been finalized to get the efficiency of the project. Other than that, the wireless power transfer principle that has been applied in this project make sure of the project built successfully. All the objectives that have been listed achieve its target. So here we got Gantt chart for PSM1 for the week first, meeting and discussion with supervisor. Week 2, PSM title proposal, pick the PSM title. Third, do the research and collect the information related to the project title. 4, preparation chapter 1. week 5 preparation chapter 2, week 6 preparation chapter 3, week 7 preparation for chapter 4, week 8 submission draft full report PSM1 to supervisor, 9 make correction for the report, week 10 submission full report PSM1 to panel, in week 11 presentation for the PSM1. So this all about my project and for my presentation. Thank you.